Alright, today in Math 20-1 we're looking at topic 6.2, multiplying and dividing rational expressions. First things first, we're going to look at doing a little bit of review on multiplying fractions. 5 over 8 times 4 over 15. Well, the top is going to be 4 times 5 and the bottom is going to be 8 times 15. But before we multiply, let's cancel first. Is there anything we can reduce? Well, I can divide 5 into 5 once. And I can divide 5 into 15 3 times. I can divide 4 into 4 once, and 4 into 8 twice. Now I'm going to multiply 1 times 1 on the top, 2 times 3 on the bottom, and my final answer will be 1 over 6. In example number 2, practice 2, I have a 4 on the top and an 8 on the bottom. So I'm going to divide 4 into 4 once, 4 into 8 twice. Now I have an x squared on the top, and I have an x times another x on the bottom. So I'm going to cancel the x squared on top, or x times x on the top, with an x times an x on the bottom. Now I have a y and a y squared. If I cancel one y with one of the y's from the y squared, I'll be left with one y on the top. Now I can't cancel anything else, so I got 1 times y, or y on the top, 3 times 2, 6 on the bottom. I'm finished. Example 1. Multiply rational expressions, multiply and then express your answer in simplest form. Identify all your non-permissible values. Well, again, before I can do this, step 1 is to factor it. So a squared minus a minus 12. That's the sum product method I can use. Find two numbers and multiply together to give me negative 12 and add up to negative 1. And that's got to be negative 4 and positive 3. Oh, first of all, I got to say x cannot equal 0 and y cannot equal 0 in number 2 because I have x and y in my denominator. Okay, now example 1. A squared minus a minus 12. That's going to factor into, as we said, a times a, and it'll be a minus 4 times a plus 3. The bottom, a squared minus 9, well, that's a difference of squares, so it's got to be a minus 3 and a plus 3 in whatever order. The top on the other side, a squared minus 4a plus 3, has to be a minus 3 times a minus 1. And the bottom, all we can do is factor an a out to get a times a minus 4. Now's where we state our non-permissible values. A cannot equal negative 3. A cannot equal 3. A cannot equal 0. Or a cannot equal 4 as we move from left to right. Now we're going to start canceling. We have an a minus 4 on the top with an a minus 4 on the bottom. I have an a minus 3 on the bottom with an a minus 3 on the top. Now I'm left with an a plus 3 on the bottom and an a plus 3 on the top. Nothing else can cancel, so my final answer is just going to be a minus 1 over 1a. Okay. This time we're dividing rational expressions. And when we divide rational expressions, what we have to do is multiply by the reciprocal. So don't be lazy, just rewrite it first. X squared minus 4 over x squared minus 4x times the reciprocal, which now will be x squared plus x minus 20 on the top, x squared plus x minus 6 on the bottom. Now we can start factoring. In the first one, x squared minus 4, well, that's x plus 2 times x minus 2, the difference of squares. X squared minus 4x, all we can do is factor out an x, and we're left with x times x minus 4. Now on the top on the other side, I'm going to have x times x, and two numbers that multiply together to give me negative 20 and add up to positive 1 has to be x plus 5 times x minus 4. And on the bottom, x squared plus x minus 6 is simply going to factor into x plus 3 times x minus 2. Now, the non-permissible values have to come from the top of the second fraction as well as the bottom of the second fraction, because it was on the bottom and we switched it to the top. So now that everything is factored, state the non-permissible values. X cannot equal, the first one is 0, the next one's a 4, the next one's a negative 3, and for x minus 2, x can't equal 2, but also on the top, x cannot equal negative 5, and 4 we've already included, so we don't have to include it again. Now we can cancel x minus 4 with an x minus 4, and x minus 2 with an x minus 2, and since nothing else can cancel, we can now express our final answer as x plus 2 times x plus 5 over x times x plus 3. Example 2. Example 3. Multiply and divide rational expressions. We have 2m squared minus 7m minus 15 over 2m squared minus 10m divided by 4m squared minus 9 over 6, so we'll have to flip that around and multiply it, times 3 minus 2m. If I start factoring as I do this, the first fraction isn't going to change, so it's going to be 2m times m is 2m squared, and when you decompose that, you're going to get 2m plus 3 times m minus 5. At the bottom, I'm going to factor out a 2m times 1m minus 5. And this next one's going to flip over to get 6 on the top, and 4m squared minus 9 is going to be 2m plus 3 times 2m minus 3. And the last one, 3 minus 2m, we're just going to put that over 1, just so we know which side to cancel on. Now I can say m cannot equal 0, m cannot equal 5. In the next one, you're going to find that m cannot equal negative 3 over 2, m cannot equal positive 3 over 2. Now I can start canceling. A 2m plus 3 and a 2m plus 3. I have an m minus 5 on the bottom and an m minus 5 on the top. Now lastly, I have 2m minus 3 and a 3 minus 2m. And in the last example, we learned that that's going to cancel out and leave you with a negative 1, which we're going to put on the top. Now when I look at it, we're almost finished, except I have a 6 on the top and a 2m on the bottom. So I can divide 2 by 2 to get 1 and 2 into 6 to get 3. Now everything's canceled. 1 times 1 times 3 times negative 1 is negative 3 on the top and 1m on the bottom. Your assignment is page 327, 1 to 10. Please do that for homework for tomorrow.